Today we're looking at the properties of operation. So your essential question is, how do I apply the different properties? Your learning intention. I'm learning to apply the commutative, associative, distributive, and identity properties. You have 2 warm-up questions. Please pause the video and solve the warm-up questions now. Well, I do hope you tried. So let's look at the first one. Order of operations, PEMDAS, says I do what first? Parentheses. So I've got 2 sets of parentheses. I go inside the parentheses. After parentheses is exponents. So the first thing I'm going to do is to simplify the 2 terms with exponents. Nothing else changes. 12 divided by 6 does not change. Plus 3 squared is 9. Next set of parentheses, 4 squared, 16, plus 8 minus 2 times 4. Okay, I've done my exponents. What comes next? Multiplication or division. If I'm looking, I've got division here, I've got multiplication here. That's the next thing I need to do. 12 divided by 6 is 2. 2 plus 9 is what's left in my parentheses, minus 16 plus 8 minus 2 times 8 is 8 is equal to. Now we are down to addition and subtraction inside the parentheses. 2 plus 9 is 11 minus. As I look, I'm going to use logical thinking. If I add 8 and then subtract 8, I haven't changed that number. 16 plus 0 is 16. They are opposite signs. I've got a positive and a negative. This is the same as 11 plus negative 16. I find their difference. 16 minus 11 is 5. The 16 is the bigger number, so it's a negative 5. Hopefully you were able to get that. If not, we'll work some more. Okay, for the next one, we don't have parentheses, but we do have exponents. And in this case, we're not even looking to solve, we're looking to simplify. I've got x squared terms. I have x terms. And then I have numbers. So I am going to rearrange. I've got negative x squared plus 3x squared plus 2x plus 5x minus 5 minus 3. I've got the like terms together. So this would be negative 1 plus 3. 3 plus negative 1 is 2, so this becomes 2x squared. I've got 2x plus 5x. 2 plus 5 is 7, so this is plus 7x. I've got negative 5 minus 3 more. I'm starting at negative 5. I'm going 3 more down the negative side, down the left. I end up with minus 8, and that is it being simplified. Okay, commutative property. What is a commutative property? Think about communication. When you're talking to somebody, it goes back and forth. Does it matter which one of you starts? No. The commutative property in mathematics is a binary operation that allows us to change the order of the operands without changing the result. So commutative means that the order does not matter. So think about the adding, subtracting, multiplying, and dividing. Which of these will be commutative? Okay, think of it as an expression. Is 2 plus 3 equal to 3 plus 2? Yes. So we know that addition is. It doesn't matter which one comes first, you'll still have the answer of 5. What about subtraction? Is 5 minus 3 the same as 3 minus 5? No. One will be a positive number and one will be negative. Subtraction is not. What about multiplication? Is 2 times 3 times 4 the same as 2 times the quantity of 3 times 4? Yeah. So if I'm looking at this, 2 times 3 times 4, is that equal to 2 times 3 times 4? 2 times 12, is that equal to 6 times 4? 24 is equal to 24, and yes it is. So it does work for multiplication. What about division? Is 3 divided by 1 the same as 1 divided by 3? No, one is a fraction, the other is not. Okay, so we're going to give an example. If I've got 2 plus 3, I'm using that commutative property. I'm swishing those two terms around. What does it become? Switch it around. Instead of starting with 2x, you'll start with 3 plus 2x. Okay, what about 5 times 4x? Once again, we're going to switch it around. Instead of starting with 5, we'll start with what? 4x times 5. Now this one can actually be simplified. 5 times 4 is 20. This becomes 20x. 4 times 5 is 20. This becomes 20x also. We can simplify in multiplication, but in addition we cannot simplify because these are not like terms. Our next property is the associative property. Think of an association. Think of a big group of people. You've got a big business. You've got a bunch of people working there. You form committees. You form groups. Do the people in the groups change? Yeah. But do you still have the same employees? Yes. So for your associative property, you're using the idea that you can move people around within that company and different groups, and you still have the same people working for you. In mathematics, the associative property is a binary operation that allows us to rearrange the what? The parentheses. And I got to erase because I misspelled. This is also the grouping. In an expression without changing the results. Okay, let's think about which operations will be associative. Would multiplication be associative? Does it matter which I multiply together first? It doesn't matter, so we know that addition would be associative. We know that if I have 2 plus 3 plus 4, it will equal 2 plus 3 plus 4. 5 plus 4 is 9. 2 plus 7 is 9. 9 equals 9, so yes, it is associative. What about subtraction? Is subtraction associative? Well, let's take a minute and look. Let's take 9 minus 4 minus 3. Is that equal to 3 minus 4 minus 9? 9 minus 4 is 5. 5 minus 3 is 2. 3 minus 4 is negative 1. Negative 1 minus 9 is negative 10. So subtraction would not be. What about multiplication? Yes, it would. So if I'm looking at 2 times 3 times 4, and then 2 times the quantity of 3 times 4, I've got 6 times 4, which is 24, 2 times 12, which is 24. 24 is equal to 24. So yes, it works. What about for division? What if I have 24 divided by 2 divided by 3? Is that equal to 2 divided by 3? So I'm going to take 24 and divide it by 2 and then divide it by 3. 24 divided by 2 is 12. 12 divided by 3 is 4. If I group the last two together, I've got 24 divided by 2 divided by 3. So I've got 24 divided by 2/3, which is equal to 24 times 3 divided by 2. That would be 72 divided by 2, which would be 36. So you can see that division is not commutative. So we've got two examples. Let's fill them out. How do we change this? How do we show this associative property with the quantity of 2 times x times y? What does it look like as you change the grouping? Pause the video now and see if you can do that. Well, it becomes 2 times x times y. I've regrouped. Instead of the first two terms, I've put the last two terms together. Okay, you've got the first example. Can you do this second example on your own? It becomes the quantity of x plus 8 plus y. That's what it looks like. Okay, that brings us to another property we use all the time, which is called the distributive property. The distributive property tells us how to simplify expressions in the form of a times the quantity of b plus c. The distributive property is sometimes called the distributive law of multiplication and division. So if we're looking at some examples, I always encourage my students to draw those lines. I have to take 4 times 3x and 4 times 5. That's the process you go through. 4 times 3x is 12x, plus 4 times 5 is 20, and we're done. But how do we use it for division? Well, 120 is the same as 120 plus 6. And I'm going to divide it by 6. So it will be 120 divided by 6 plus 6 divided by 6, using the distributive property. 120 divided by 6 is 20, plus 6 divided by 6 is 1, and you get 21. For the last two, we've got identity properties. What does identity mean? If you're talking about your identity, what are you talking about? Well, you're talking about who you are. So you are who you are. In multiplication, what do you multiply a number by? So you get that number back. It doesn't change the number when you multiply by this number. For the identity property of multiplication, we're talking about 1. 1 times any number gives you the number back. So 1 times a equals a times 1, which equals a. So let's apply that same idea to addition. What number can you add a number by and get the number back? 0. 0 plus b is equal to b plus 0, which is simply equal to b. So how do you know when you're successful? You know you're successful when you can apply the commutative, associative, and distributive properties. So we are applying the commutative, this is order, does not matter. The associative, which means the grouping does not matter, and the distributive property. Okay, I could show you an example of the distributive property, but we will leave it as it is. So hopefully this helps you to understand how to apply properties. If you're still struggling, come talk to me.